Determine for the function g of x equals 5x minus x squared for x is less than 1 and 1 plus 3 over x for x is greater than or equal to 1 at the x-coordinate x equals 1, whether it is parts A through D. The parts involve whether it has continuity and differentiability. So let's start with continuity. At the x-coordinate of 1, the definition will be the limit as x approaches 1 from both sides of g of x will equal g of 1. In order to work out the two-sided limit, we have a split expression function that is changing right at the x-coordinate of 1. We will have to work out the two one-sided limits separately. X approaches 1 from the left side of g of x, and x approaches 1 from the right side of g of x. Let's start with the left side. The left side means less than 1, and that means we will use this expression for g of x. So we have the limit as x approaches 1 from the left side of 5x minus x squared. We can now plug a 1 in for each of the x's. That will give us 5 times 1 minus 1 squared. 5 times 1 is a 5. 1 squared is a 1, so 5 minus 1, which will give us 4. We will now work out the right side limit. And the right side of 1 means greater than 1, and that will indicate we use this expression for g of x. 1 plus 3 over x. We can now plug the 1 in for each of the x's. That will give us 1 plus 3 over 1. 3 over 1 is a 3, so 1 plus 3 comes out to 4. The last thing we need to look at is g of 1. G of 1 is g evaluated right at 1, so we look at the split expression function where we include a 1 that's there. We use that expression, and we plug a 1 in for dx. And this is the same result that we had for the right side limit, so we have 1 plus 3, which also comes out to 4. All three of those match, and therefore, with the left and right side limits matching each other, the overall limit is a 4, and it does match the g of 1, which itself is a 4. So we do have that it is continuous. Now we want to determine if it's differentiable. To determine differentiable, we're going to determine the continuity of the derivative of g of x. So we are now going to take the derivative of each of the expressions. The first expression, 5x minus x squared, the derivative will be 5 minus 2x, and that will exist for x is less than 1. And the second expression, 1 plus 3 over x, which can be written as 1 plus 3x to the negative 1. The first term is a 1, the derivative is a 0. The second term is a power rule. Bring down the power, we have negative 3. And then subtract 1 from the power, so it'll be x to the negative 2. And this will be for x is greater than 1. We cannot determine if we can include the 1 just yet, because that doesn't happen until we see it's differentiable. So we strictly say greater than for now, and then we'll put the equals to later if it turns out it is continuous on the derivative. Let's rewrite the look of this derivative. Just the second expression. The first expression I'm going to leave alone, but the second one I will rewrite by moving the x to the negative 2 back to the denominator. So we can call it x to the positive 2 in the denominator. And now we're going to determine the continuity of the derivative, and that is called differentiable. Limit as x approaches 1 from both sides of the derivative have to match the derivative evaluated right at 1. The two-sided limit will need to be evaluated from each side separately because the derivative itself changes its expression right at 1. So we have the left side limit of 1. We have the right side limit at 1 of g prime of x. Let's start with the left-sided limit. The left side of 1 means less than 1, so we will use this expression for g prime of x. 5 minus 2x. We can now plug a 1 in for each of the x's. That will give us 5 minus 2 times 1. Minus 2 times 1 is a minus 2, and 5 minus 2 comes out to a 3. Now we will look at the right side limit. The right side of 1 is greater than 1, and we will use this expression for g prime of x. So we have negative 3 over x squared. We can plug a 1 in for each of the x's. We'll have negative 3 over 1 squared, which is negative 3 over 1, which is negative 3. The two-sided limit requires the two one-sided limits to match each other. These actually do not match each other. And since they do not match each other, the limit as x approaches 1 from both sides of g prime of x does not exist. And once that does not exist, there is no way that can equal to g prime of 1. And so since those cannot equal, you do not have a continuous derivative, and that means that it's not differentiable, and also we cannot put an equals on this greater than 1 for either of these. So our result is we are continuous, but we are not differentiable. That's situation B. Continuous, but not differentiable.